to decay into the products. So anytime I ask what is the half-life, you're going to give me a time. So here in our graph, the black dots represent the parent atoms, the unstable isotope, and the red dots represent the daughter atoms, what the unstable isotope has decayed into in the form of products. So we start off with 100% parent atoms, 20 atoms that are the parent. At the first half-life, 10 of the parent atoms remain, and they are replaced by 10 of the daughter atoms. In the second half-life, half of the remaining parent atoms from the second half-life are decayed, and they are replaced by daughter atoms. So we have 5 parent atoms, 15 daughter atoms. And then half of the remaining parent decay as we go to the third half-life, and we have 2.5 parent and 17.5 daughter atoms. So we're going to look at the radioactive decay of iodine-125. And we want to know what is the half-life of iodine-125. So we want a time. We're given this graph, and we can read on here that at time 0, we have 600 grams. So when half of that has decayed, it'll be 300 grams. So we find 300 on the graph, go over, here's our 300 point, go down, and we find the time, which is 60 days. So we can see 60 more days. So this is first half-life, second half-life, 60 more days, third half-life, 60 more days, fourth, and 60 more gets us to our fifth half-life, which is 300 days. But say you don't have a graph, but you know how long one half-life is, and you know how many half-lives have passed. So you can take the 60 days for one half-life, times the number of half-lives, which is 5 half-lives, and you will get 300 days as well. We also want to know what the percentage is that remains. So we are going to start with 100% of iodine-125. When half of that has decayed, we are left with 50% at our first half-life. Second half-life, 50% of this is going to decay, so that's going to leave us with 25%. And then at our third half-life, we have half of this, which is 12.5%. We also want to know how many grams of iodine-125 are left after 3 half-lives. So we can take a look at our graph here, 3 half-lives. It's somewhere between 50 and 100, but let's do some calculations to make sure we know exactly how much. So we're starting with 600 grams. This is at time 0. At the first half-life, half of that has decayed, so we have 150 grams remaining. Or, sorry, that's my bad. Got ahead of myself there. We have 300 grams remaining. Half of that is 150, which is what we would have at our second half-life. And then third half-life, we have half of that remaining, so we have 75 grams remaining. Here's your half-life equation. A equals A sub 0 times 1/2 to the power of little t divided by big T. So big A represents our final amount. And that's going to be a mass. Probably in grams, but it could be in kilograms or milligrams. But some sort of mass. A sub 0 is the initial amount, or starting amount, the amount at time 0. And again, that's a mass as well. 1/2 is a constant that we always multiply by. Little t is the total time. Or the elapsed time, the time that has passed. Big T is the time of a half-life. So we can use this equation to calculate for any of these different variables. The half-life of chromium-51 is 28 days. If a sample contained 510 grams, what mass would remain after 56 days? So whenever I go through word problems like this, I like to underline the information that I'm given and figure out what variable that is in my problem. So the half-life is 28 days, and we said that the variable for half-life is big T. The sample contained 510 grams, that is the A sub 0. The mass that would remain, that is our final amount, so that's A. And 56 days is our total time. So our equation A equals A sub 0 times 1/2 to the power of little t divided by big T. So we're trying to find A, so we're going to write that down. Equals 510 grams multiplied by 1/2 to the power of little t is 56 days divided by 28 days. And you should get 127.5 grams. We also want to know how many half-lives have passed. We can take our total days divided by the number of days for one half-life, and you should get 2 half-lives. Part B asks what mass would remain after 260 days. So 260 days is going to be our new total time. So A equals 510 grams times 1/2 to the power of 260 divided by 28. And you should get 0.817 grams. To find out the number of half-lives, you take 260 divided by 28, and you should get 9.29 half-lives. If you're having issues putting this into your calculator, you want to come by and see me. I don't want calculator issues to be your problem, so make sure you come in and ask questions. This problem says a sample initially contains 100.0 grams of thorium-234. After 16 days, the sample contains 63.1 grams of thorium-234. And we want to calculate the half-life. So the half-life, that's big T. Little t is 16 grams. So A sub 0 is 100 grams. And 63.1 grams is A. So in our equation, A equals A sub 0 times 1/2 to the power of little t divided by big T. 63.1 grams is A. A sub 0 is 100.0 grams times 1/2 raised to the power of 16 days divided by big T. In order to solve this problem, you're going to need to use log functions, and not all of you have had the math necessary in order to understand those log functions. So I'm just going to tell you that T equals 24.1 days. I also wanted to just go through another problem and figure out where things fit into the equation. But we also need big T in order to calculate part B. So now we're asked what amount of thorium-234 remains. So that is big A after 1 year. And that is our new little t. So A is what we're trying to find. A sub 0 is still 100.0 grams times 1/2 to the power of, and we have years and days, so we need to convert those to the same units. So we're going to have 365 days divided by 24.1 days, and A equals 0.00276 grams. So that is it for half-life notes. You have practice problems on the next page for half-life. Make sure you work through those, stop by and ask me questions if you have any. And we only have one more lesson before the end of this unit, so you want to make sure that you're getting caught up on everything and asking questions if you are struggling with anything. Thanks for stopping by. Have a great day.